Welcome, everyone. I'm Anil Sener. I'm from Microsoft. I'm an AI cloud solutions architect working in UK. Today, I'm going to talk about generative AI with Azure Machine Learning Service. Just before starting, I would like to just know more about you. I've seen some hands. I understand the population here a bit. How many people consider here as AI engineer or data scientist? Okay. How many people can consider himself as a data analytics database manager, database admin? Just one? Incredible. Why? It's still fun. And how many people thinks that he's or she is very good software engineer here? Okay. Okay, we will try to find out material for all of you. Okay. So just to introduce myself, I'm Anil Sener. I'm from Ankara, Turkey, the capital of Turkey. Father of a little boy, AI and analytics experts. I'm working in customer success in Microsoft. I was and I am still a data science lecturer. I'm really interested in autonomous AI, computer vision, and NLP. So nowadays, the name is not mentioned a lot, but we are actually working a lot about autonomous AI. So, and this is my first creation actually in 2017. It's a deep dream version of a sea turtle. So many people around 2017 started to play with generative AI actually. And one of the first things that I did was to take a session about generative art with generative AI. So it was teaching about this stuff, deep dreaming, which is a method, and it has the same problems that we are facing today. It hallucinates, it generates some content, it brings content from its prior knowledge. It has the same problems, same nature that we have. If it doesn't hallucinate, it's not creative at all. So I just wanted to show as my profile picture my first creation. At that time, we were playing with autoencoders, generative adversarial network. So this stuff has been there for a while. But why it didn't become productive? Why it didn't become, at that time, so popularized? I want to just start before even getting into my real topic, because our colleague from Google really started to talk about exams, and I was also playing with exams, so we are like twins in other companies. So it's about GPT-4 Vision, which is announced just today, and in OpenAI, of course. And I was playing with that just to extract some text about the students' responses, and I was trying to also extract some information with respect to the comments of the teacher. So this is the task. Actually, probably I should have started just capturing the questions, right? I should have done, but I've forgotten. So I just wanted to show this as a fun example because you can see that with exams, actually, we can really understand using multi-modal inputs, not only text, what is written, and in a very bad handwriting, actually, in different colors. We can distinguish them, although they are overlapping. And we can give clear instructions to separate the content. And as you can see, I was able to capture the students' answers very well. And just putting the students' answers to the context, but asking additional questions, I can directly, quickly ask what's the overall mark, what's the comment, and what are the responses. Actually, it was so smart that it was giving the answers to me. It was saying to me, these are correct, and this is correct because of this. But I put so many controls over that I was able to just take many check marks and just what I'm really interested in taking. So this kind of process that we have observed here, we will be gradually repeating again, and trying to find out the intended results when we try to work with generative AI. So when you are in a chaotic environment, having control and observability is essential. So today you will see lots of interesting announcements in Microsoft Ignite conference. I guess I'm the only person in Microsoft Teams not looking at Ignite at the moment. So we mentioned about Azure AI there. We mentioned about billions of copilots that we have built, and we have built Azure AI based on our work in the last 3 years. Actually, it's not really just happening. We have been working on these things for a while. So we talk about some SaaS-based copilot solutions built for particular purpose, like Security Copilot, Bing Chat Copilot, M365 Copilot, Power Platform Copilot. As a vendor, as a cloud provider, we have one distinction from the other competitors. We have productivity tools. And when you combine this with these foundation models, the solutions become so powerful. So one of my favorite tools in Microsoft is Excel. And I'm so eager to play with it using M365 Copilot to generate some reports. But behind the scenes, we have the platform as a service products, PaaS platform products. We collect them under Azure AI portfolio. Some of these products have some pre-trained models, and they are just focused on a particular purpose, like document intelligence, the boring AI, which is the useful AI actually. Cognitive search, Azure AI search, which has vector, keyword, and semantic ranking capabilities. And we use often in our projects. We have AI vision services, which had many new announcements today. Speech services, we have been beating the benchmarks for many years. Language services, we didn't start language modeling with OpenAI. And Azure Machine Learning Service. Today, I'm going to talk about Azure Machine Learning Service and how it's used for generative AI. And we have the AI infrastructure that backs that. Azure Machine Learning Service is a general purpose machine learning platform. And it has been adapted for generative AI use cases in the last 3 years. Just to understand, I mentioned about this initial example, how I get started with it, how I developed it, how I added some context, how I evaluated it, how I operationalize it. It has a common pattern that almost every generative AI engineer facing nowadays. And in Azure ML platform, this was missing actually for a long time. All of the general purpose machine learning services didn't have this functionality to help the people, the users, to get started easily, to develop stuff and test them, add some data inside, evaluate them quickly in relevant metrics, and operationalize it. So these were missing things, and these are things that are really slowing 99% of the organizations that we have been dealing lately. And this created some differentiation from typical machine learning, LLM life cycles in real world. So in typical MLOps life cycles really doesn't resemble to what we see in LLMOps requirements or foundation model operational requirements. With Azure Machine Learning Service, we are trying to solve this. And we are dealing with different personas. We are trying to involve, simplify AI, open it to more people. We are trying to bring app developers to contribute to the process. We are trying to bring even domain experts to contribute in the direction of these GPTs, these foundation models, because it empowered us, but without domain knowledge, without clear instructions, we observed that we don't reach the results, even if we are the best developers. And we start to get involved from, leave the traditional things that we are playing with, and we started to use things like agents, third-party APIs, creating chains, using complicated evaluation metrics that means hardly anything mathematically. And we don't go with simple algorithms anymore. We use really large models. We tend to not train them from scratch anymore. We try to fine-tune them or adapt to certain purposes. So for this lifecycle, we initially, start with probably trying to use our data in many organizations, in many companies, without even adding context, without adding any own data. It's very hard to create something useful. So when we started to launch OpenAI, one of the first examples that we opened was about enterprise search with OpenAI. So most of the iterations, we recommend our clients to test out how to add data and get responses from that. And then start prompt engineering techniques, or aka in autonomous AI verse, machine teaching, to control models' understanding about the process. My colleague also mentioned about we are just like as if we are dealing with a baby. And this is true, because we are dealing with a baby, we are teaching, we are interviewing with it in a sense. And we are trying to show what's useful for us actually. And prompt engineer, in my opinion, is just a subset of machine teaching. So in the future, we will be talking more and more about machine teaching. We are just saying it's prompt engineering nowadays. Fine-tuning. Fine-tuning is the next step. If you can't handle your problem with typical prompt engineering, you would need to probably think about fine-tuning your models for a domain-specific cause. And you can really get some interesting results with that. But we really recommend it as a later stage, just to have comparable results and just to have a procedural approach. And finally, training from scratch maybe. It might be necessary in some cases. Azure Machine Learning Platform has been providing a wide ecosystem of tools for developer productivity, collaboration, and based on AI infrastructure. I'm not going to really get into deeply this because these are not inherited totally only for generative AI, but we have, of course, some automated machine learning features, some low-code features, we have feature stores, we support many different languages, we integrate with other technologies in our platform. We have been building declarative MLOps for a long time, and we recently announced tools for LLM ops. Actually, we were the first one for this. We have enterprise-grade security that you have full control, where you can deploy your own models. And these models can be from different spectrum. We have announced some new GPU types today. AMD GPU types also were added to our portfolio. This is just a boring Azure Machine Learning, what's Azure Machine Learning slides. What we are going to talk about is Azure Machine Learning for generative AI. So generative AI requires a model catalog. It requires capabilities to handle and assemble prompts and compare different versions of prompts. It requires creating agents which are safe to use and controlled. It requires monitoring when they are actively in use. And it requires purpose-built, economically scalable infrastructure. As of today, we have expanded our community models as well. And apart from Azure OpenAI service, we have in our portfolio Hugging Face, Meta. Actually, this list is not very comprehensive. We have Code Llama as well, MN detection, and NVIDIA models. So we have computer vision and natural language processing models in our portfolio. More is coming. So we have, I mentioned the Azure Machine Learning Model Catalog. It's a central area where we have either curated models or community models that are accessible and easy to deploy. I can't express how difficult it was just to deploy a control net like a year ago. I don't remember selecting the right instance size, ensuring that I have the right installations done, having the processing running in a normal time frame, bringing the data in. It was so difficult. People were really fearing and they were just giving up. Even the most capable software engineers were just giving up. This is about it. You can access most of these models from open source models from our side. But with this tool, with our reusable components and pipelines, you will be able to do it much faster. Because as data scientists, we are racing against time and budget to deliver and test, evaluate quickly, and to create reusable stuff and show to the people that we can do more. in a shorter time frame. As I mentioned, like model catalog is very improvised with what Hugging Face done with these model cards, where you have model in the center, the description, its use cases, examples, tasks, modeling tasks that it can do, licensing, which is very important, whether you use it, whether you can use it in production use cases or business cases. So it's an environment where you learn about the model and what you can do with it. You can even test it out, test some models without having to deploy here. We have added vision models lately to this portfolio. We have models from both NVIDIA as well as in our detection and some open source models here. We support typical use cases like object detection, image segmentation, text to image, and image to text. I can say that many people think about foundation models capability as our own only or most interesting generative AI capability. But in fact, we had some machine learning, we had used of transformers already in our ecosystem thanks to automated machine learning. And in our automated machine learning tool, we have the ability to select the best features. We have to do automatic feature engineering, select and rank the algorithms, do hyperparameter tuning, and find out the best model in a model leaderboard. What we have added lately to it is the ability to handle images and textual inputs. So we are able to handle these task types alongside tabular automated machine learning tasks. And we are able to use almost all the models, I think, in Hugging Face in our model catalog. So this became like also a second level of testing out many models in the model catalog quickly, in a sense. And testing out many approaches to use them, in a sense. So I wanted to highlight it. One of the accelerators will be that, without having to explore everything, just testing out several models in the catalog, feeding your data, trying out some separations between your training and test data sets, and just evaluating your results. It will be compute heavy, I admit it, but you will be able to do a lot in a very short time. So I want to get into, after these basic functionalities, I want to talk about what do we need to generate an autonomous agent. So my colleagues really mentioned about databases today. Databases are just long-term memory in autonomous AI literature. A prompt context is a short-term memory. So it's called also in-context learning. But memory is not good enough without ability to use this memory, this information, this knowledge, right? We need some capabilities to take actions over this memory, to ability to retrieve this memory in the right time and the right context, maybe revisit it again and again. And we might need some additional tools to do things that large language models or vision models cannot do, okay? So it is actually a concept of a brain, okay? And with the applications that we are doing, intelligent applications that we are doing, actually we are designing autonomous agents. Our new product, Azure Machine Learning Prompt Flow, is our LLM product, you can say that, but at the same time is our product that allows you to create autonomous agents, combining one or multiple foundation models, your existing databases, vector databases, knowledge bases, your tools, and combining it with a mechanism to control your application development for CI/CD, and ensuring that the applications developed are safe and responsibly built. So Azure Prompt Flow is one of the most interesting functionalities that I have heard in Azure Machine Learning Service. I think this video will explain it to you in a very short way.
Welcome to Prompt Flow in Azure AI Machine Learning Studio, where develop.
Is it too much?
It's too loud. We can hear it.
So is that changing?
Yeah, I will reduce it. Sorry to burst your ears.
Developers and data scientists can seamlessly incorporate large language models using natural language as a part of their application. Prompt Flow, currently available in Azure Machine Learning, provides a streamlined experience to quickly create prompt workflows that connect large language models to your organization's data to create intelligent applications. Developers can use Prompt Flow to write, iterate, and evaluate their prompts to better condition their large language models for desired output before deployment. Plus, Prompt Flow works with Azure OpenAI service models, open source models, LangChain, and semantic kernel. Visit aka.ms/prompt_flow to learn more on how to deploy foundation models on Azure AI.
So this was a very quick tour of its capabilities, but basically it's a tool which offers you a DAG, a directed acyclic graph, to orchestrate several tasks. It can work like a planner. But it's a directed acyclic graph. Some requirements that we have seen, like React pattern, the Flare pattern, they require cyclical patterns. You can build this inside this tool using Python functionalities, just embedding LangChain and semantic kernel to your Python steps, in a sense. So, in a sense, it's a tool to orchestrate. Awesome. There is another echo over there. It helps you to test and evaluate your flow, in a sense, not only the large language model, because the flow is end-to-end. It helps you to manage different versions of the prompts. You know that when we started this thing, we were keeping like 100 versions of these prompts, and we were really unable to see, especially at scale, what's the impact of every change I did in the prompt. And this is really important. And the ability to compare and deploy them. So, in a sense, this brings several capabilities. I'm just skipping the things that it mentioned here. It brings capabilities to connect the vector databases in general sense. I'm not going to repeat the retrieval augmented generation topic 10 times that you might have seen. In a sense, we can define connections. We have some built-in connections to Azure Cognitive Search and also other services in our portfolio. We can define custom connections. So if we wanted to add probably to Astra to this context, we would probably define a custom connection from this list. Or we could probably use a LangChain flow because I think AstraDB supports it. And simply, we can evolve it to our flow. We can define different variants of prompts in our definition, in our language flow. We can version them definitely. We can evaluate them. For every variant, we can generate different evaluation results. We can deploy them to managed online endpoints. You know what? One of the first things that was striking me when we released the initial accelerators, I have seen app service had this autonomous agent, Azure AI App Service, which is typically used to develop some applications, but general purpose applications. What does this mean? You would need to ask the software engineering team or web development team to embed this very complicated flow inside there. In terms of collaboration sense, it doesn't make sense. For most of the cases, it would really make sense to create your language flow autonomous agent as a separate microservice and deploy it in a managed manner as a managed online endpoint and serve it to your final application front end. So it brought us capability to handle more complex patterns and still working in parallel without blocking each other and focus on our expertise. Initially when it was released, it had only UIs and some capability to ingest some code. People ask, how are you going to share the code? How are you going to maintain the CI/CD? Finally, we released the code experience as well. So you can do this development on your local as well. So you can develop your autonomous agent development in your local, and you can do the initial iterations, but when you want to run it at scale, bulk testing, you will deploy it into the cloud. these are just examples of, you have the options. Some people are cloud friendly. They can stay on the cloud and just do the full development on the cloud. We have the UI there. We have the version of VS Code web over there as well. Or you can do some of the development, flow creation, creating some of the scripts locally, testing them locally. And then you can commit to a repo, and over that repo, you can start a bulk testing to evaluate multiple variants. And just regress them in a sense. You can opt for deploying to an endpoint. You can deploy multiple models to the same endpoint. You can do A/B testing, so you might want to evaluate different approaches at once. We have some tools for this to work on locally. How much time do you have? I think there is open. Yeah, 45 minutes, seconds.
It's like less than 5 minutes.
Okay, let's finish. And then, a prompt flow, in a sense, provides a functionality for us to intelligent application development. But after you deploy these models, you should be able to monitor what's going on in these models. And we have recently announced a new add-on to our model monitoring stack, a generative AI model monitoring, where you can do model monitoring over your prompt flow models or regular models, foundation models, and you can measure very relevant metrics like groundedness, which means like are you basing your responses based on facts, fluency, coherence, similarity if you want exact answers. So metrics that are really relevant to generative AI development. And you can raise alerts. You can decide drifting decisions. So you might have a more experimental model, and if you feel that it fails, you can drift to a simpler model that you used to use. We have a tool for responsible AI content safety. This is a separate service we have, which can be plugged to OpenAI or Azure machine learning service to ensure that you can control the level of safety for different dimensions like violence, self-harm, sexual, and hate. I can say that having this control is very important because when we released our content safety platform in the beginning, it was just the same thing for everyone. But the needs for every customer is not the same. So I had a lot of advertising clients, and they definitely like sexuality to be put into their videos. And they didn't like to be blocked by a sexuality part. So they are able to tune back. So this service can be pluggable with Azure Machine Learning Service. It's basically some API calls that you will be enforcing on inputs and outputs. So you can get a healthy inputs and you can get out healthy outputs. We have capabilities for responsible AI. We have announced text dashboards lately where you can do feature explorations, error analysis for NLP use cases. We have also image dashboard for responsible AI where you can find out feature explanations for computer vision cases. And today we announced Azure AI Studio. I didn't include this because it was being announced just now. And I highly recommend you to take a look at this video. Thanks for listening. I would like to take their questions now. Yep. Please.
So at the end of the flow, there is this, in the test, you have some sort of metrics to determine the efficacy of each model and what have you.
Mm-hmm.
Is there a documentation of, at least a detailed explanation of each of the metrics that can be selected and why, how with the behind the scenes of these metrics and stuff?
Yeah, definitely. And even in the future, there is capability to define your own metrics as well, by the way. Definitely, how they are calculated, which formula is used to calculate each of them, and what's their use is mentioned. So, for example, I mentioned groundedness. To fight with hallucination, one of the things that you should be really taking care is how much groundedness you are really interested in. And these metrics are calculated just, as my colleague mentioned, thanks to GPT-4 actually. GPT-4 becomes, an LLM becomes your referee in a sense. Okay? Some of these metrics are calculated thanks to the answers of GPT-4.
So my question would be, if you have GPT-4, so you have, so just say I don't have a source of truth. Okay, a simple use case would be summarization. So I have one use case where I have summarization, text summarization, sorry, about text and then push it through. In terms of how would they do the actual calculation to determine A or B is better, unless you have C, which is me putting in what is the actual a human input basically.
Very good question. So I have seen the GPT-4 prompt, system prompt, which creates that groundedness metric, for example. What they have there is they have a system message. You are an evaluator. You are the master evaluator. And here are some five-shot examples of good summarization. I have given input 1 and summary out. I give it 5. Input 1, fifth-shot examples. So they have given fifth-shot examples of that. And there it is. Your referee is ready, right?
So you use the few shot examples.
Exactly. Exactly. You had a question.
Yeah, you start the main presentation saying mapping who we are in the building from the skill point of view. And my question is, according to you, which kind of skills, if you want to run this type of advanced, let's say, generative AI, or which is the priority of the skills that you need, or you don't need any skills, anyone can run it?
So I can't say that for someone who is going to buy or build a product, there should be one skill that's very essential that you cannot buy from outside. It is about the positioning of the AI product. So you should have in your organization someone who is able to position the AI a product that uses AI in the right use case. So you need this essential skill. Apart from that, you can try to outsource the rest of them. But at least this skill, in my opinion, like must-have skill. So someone like a business analyst should be able to just understand the governance impact of the solution that they are trying to build, the user base that will be using these products, the unintended consequences of it, intended consequences of it. So bring all these things together for a successful project. In my opinion, this is a success criteria. Successful, it's the most important ingredient for success, let's say. But of course, for a full stack project, technically, you will need someone who understands the foundations of data science. We can't say that, okay, application developers are really empowered to do a lot. But you would need at least a data scientist to be there as a free referee, like someone to look at what's done and look at critically, find out the open points for it, even if he or she doesn't do real big development. You need a good someone who is able to think about in the data science mindset. Apart from that, you might need software engineers, definitely. Even some database experts, knowledge base experts, search experts might be needed per project. Because you are still using your knowledge bases, you are still trying to ensure that the lower levels are secure enough, you do the separations there, you work enterprise grade. Yeah.
That's all the time we have for
Awesome.
questions. Thanks
Thank
a
you
lot
very
for the talk.